Has anybody heard of the call stack? I'm pretty sure Chad may have mentioned it on Saturday. If he has, can anybody give me like kind of like a rundown of what the call stack is?
Yeah, from what I understand, it's like a structure that it's a first in, last out structure. So you're gonna pass in your first call. It'll move the process almost to the structure. And as they complete it, pops them back off. And it's particularly important in recursion because your first call to the function is going to go in, and then every time you recursively call it, adding another layer to that call stack. So actually, your most recent call is going to be the very first one that pops off the stack, and then you'll go backwards, and so you'll basically count down. If you made 10 calls, call 10 is going to come off the stack first, and so on and so forth.
Yep. Yeah, that's exactly it. Has anybody heard of a stack before, and why is it called a stack? Has anybody heard of a stack before?
You can't like, it's like if you're stacking books, you have to take the top one off before you take the one under that off. And
Yep.
so.
No, yeah, exactly. So a stack is a specific type of data structure that can only operate in a specific type of way. So a stack, which is, does anybody know what the opposite, like the inverse of what a stack is? So if a stack is last in, first out.
A queue.
A queue. So if you're like standing in line for a roller coaster, it's first the one to get in line is the first one to get on the ride. So a stack is a last in, first out, a LIFO, whereas a queue is a first in, first out, a FIFO. And that's important because once we start to get into data structures, so again, a stack can only operate last in, first out. So as you said, like a stack of books or a stack of pancakes, when you make pancakes, you put them on the plate and now you have a stack of pancakes. When you go to take off a pancake, you take off the top one. All right. So yeah, what is a call stack? A stack is a type of data structure. A call stack stores executions of code on the stack in the order they are executed and removes them from the stack when they are done executing. And again, as you mentioned, this is relevant to recursion because recursion continuously executes a function until it doesn't anymore. And then it removes all the running functions off of the stack in the order that they are executed using last in, first out. So there is a way to do it in to stimulate the call stack in VS Code. I'm just going to show you a visualization of this here. So over here on the left-hand side, can you all see this code or is it difficult to see? I'm sorry?
Affirmative, we can see it.
Okay, cool. So we've got three functions. We've got a main function called main. We have a second function called second, and we have a third function called third. And the main function has a console log that says main starting, and then it calls the second function. And then once it's done, it just returns the main removed from the call stack. So in the order, when we visualize the call stack, the first function is called, it's put on the stack because it's currently executing. So if I were to visualize this, so this is the call stack. The main, when I invoke main down here, the main is executing, it's being put on the call stack. So now if we read the code, main is executing. The next thing that's going to be put on the call stack is this console log. So console log, main starting. But the console.log function just immediately, once you console log it, it's done executing. So then the console log gets removed from the stack. Then we come down here, we get this, we're invoking or calling the second function within the main. So then the second function gets put on the call stack. All the while, the main function is still executing. It has yet to return anything. So now we're down here in the second function. So second, now we're going to console log second starting. And then console log it just immediately is done executing. It gets removed from the call stack. Now we jump down to here to third. So the third function is being called within the second function. So now the third function gets put on the call stack. So if we just come down here to the third function, we get console log third starting. And then the console log is immediately done. And then we come down here, then we return the third. So while this is all happening, the main function is still executing. It's still running its code. Same with second. The second is still running. Like that function has yet to, it's not done executing. So once we get the third starting is removed from the stack, and we return third removed from the call stack. All right, there. So third is done. Now we jump down. So third right here is done executing. Now we jump down to the return from the second function. The second gets removed from the call stack. And down here or up here where second is just returned. Now we're going to return main removed from the call stack. So that is the call stack. Any questions on that? So the call stack, we will also come into play in web development in something that is called the event loop. So if you ever hear the event loop, it consists of a call stack in addition to a queue. It's but we'll get into that later on once we actually get into web development. So that is the call stack. It's just the order in which the functions are being called, and that the fact that they're being executed while all the other functions that are placed on the call stack are also executing. And again, the stack last in, first out. So just like this, the last one to go in is the first one to come out. So yeah, any questions on that? Oh. All right, so now let's talk about recursion. What are two things that you need to write what are two states when writing a recursive function?
A base case and a recursive case?
Yep. So we need two things, a base case and a recursive case. What is a base case?
One that should stop when basically when it should stop.
Yep. So what condition will stop this function from essentially just return the function? When we should just return something other than the function? And then we have the recursive case. So what is the recursive case?
When it should call the function again?
Yep. Yeah. So again, just a recursive function is a function that continuously calls itself until it reaches a base case, and then it no longer calls itself. So process in which a function calls itself requires two cases, a base case, the condition in which the function stops calling itself, and the recursive case, the case in which the function returns itself. So if we have a function down here, sum up to, so sum up to some specific number. So for example, if we want to calculate the sum up to 5, so if the 5 is the input, we want to sum up 5, 4, 3, 2, 1, and then figure out what that sum is. So if we want to do, what's the sum, like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and figuring out what the sum of all those numbers are. So if we're gonna, so here, when this function sum up to, the base case is once the number, the input number equals 1, it just returns 1. Else we run the recursive case. We return the number plus, we call the function again, but num minus 1. So for example, up here, if sum up to 5, if we would type in 5, when we initially call it up here, we pass in 5. If 5 equals 1, no, that's false. So then it jumps down here to the recursive case, and we return 5 plus sum up to 5 minus 1, which is 4. And then we pass that into the sum up to function again. If 4 equals 1, which is not true, so that's a falsy value. So it jumps down here into the recursive case, return 4 plus sum up to 4 minus 1, which is 3. So it calls the function again, and it keeps on doing that until it reaches 1. So we call 5, 4, 3, 2, 1. We pass in 1 in the sum up to. If 1 equals 1, that's true. It just returns 1. So at the end of it, we get 5 plus 4 plus 3 plus 2 plus 1, which equals, I believe, 15. And again, for the call stack, when I pass this 5 in, this function, the sum up to 5, this version of the function is continuously running all the while, like sum up to 2, sum up to 1. So all these functions are executing while the function, until it reaches the base case. Any questions on that?
I don't know if there's a question or not, but something that kind of clicked for me during Chad's lecture was that each of those on the call stack are basically just waiting for a value that they need to plug into their function. And so if you look at that, the last time the recursive function runs, what it's going to get back is the return value from the base case, correct?
Yep.
And then it just goes down the stack, filling in what that function would return, plugging it in.
Exactly. So what's actually happening is we're calling the function 5 times, and we're getting 5 plus 4 plus 3 plus 2 plus 1 throughout that entire, all these functions being called. This is unrelated to recursion. Does anybody know like the quick mathematical trick to get like the sum up to 5? So if this is 5 plus 4 plus 3 plus 2 plus 1, there's an actual mathematical trick to actually get this value, which is 15, by doing just like a simple mathematical trick. Does anybody know it?
Does it
Reduce,
do with, does it
or
have to do with a bang, like bang 5 or something?
Nope. So, sum up to 5, 5 plus 4 plus 3 plus 2 plus 1 equals 15. All you have to do is take 5 times 5 plus 1, so which is 6, divided by 2. So 5 times 6 equals 30. Divide that by 2, that also equals 15. So that works in any case. So if I want to do sum up to 100, instead of doing 199 plus 98 plus 97 all the way down to 1, I can say 100 times 101 divided by 2, and that also equals the sum. Just a random mathematical trick. If anybody wants to, they can quickly calculate something like that. And if it might come, and if it ever comes up in an interview, because you can solve this recursively, which is O of n, or you can just solve it in constant time, which is just a quick mathematical. All right. So any questions on recursion, the call stack? All right. So I'm going to open up VS Code. And did somebody want, you wanted me to go over, what is it, Factorial? Is that correct?
Yes, please.
All right. with that. What day was that? That was Saturday. Is that this? Is that this one?
Yes.
All right. So what I'm gonna do is fork this over. Did anybody want me to go over any other ones? From this challenge?
Not from this challenge, but I wouldn't mind going over the Boggle challenge using recursion.
Oh. I'll have to think about that one. Yeah. But yeah, that's actually good. We'll do that at the end of the end of the night, or I'll just record the video and just upload it for y'all to have. All right, so what do we
Thank you.
have? Yeah, no problem. We got recursion 2. And we said Python. All right. So Factorial 2, or I'm sorry, Factorial is very similar to this one right here. Let me actually get out of that. So the sum up to, I'm just going to copy this over. So let's just first figure out what the base case is and the recursive case. Cases. So what is the base case? So again, Factorial is very similar to the sum up, except you want to multiply. So 5 times 4 times 3 times 2 times 1 is Factorial. So what would be the base case? Anybody?
If num equals 1, return
Okay.
1.
So if I guess it'd be x equals 1, just return 1. Else, what do we want to return?
So if we're following the same example, it should be like return x times factorial parentheses x minus 1.
Yep. Let's see if this actually works. I don't even know. We can actually write some test cases for it. Let's go ahead and do that. What do we got? So I'm going to split the screen here. So I'm going to import unit test class test factorial, or I can just say like test recursion. What is it? Import. Is it unit test dot test case? Is that the class I'm inheriting from?
Yeah.
All right. All right, so I can do def test factorial 5 self. What is factorial 5? 5 times 4 is 20 times 3 is 60 times 2 is 120. So is it 120? Or is my math totally off that with that?
I think it's 120.
Right.
Cool. All right. Test factorial 5 should equal 120. So self dot assert, was it equals? Is it equals or equal? I don't know off the top of my head.
I think it's equal. without the
Equal.
S.
That's equal.
All right. So I can do, I have to import from recursive challenge, import factorial. So factorial 5. I think this is the syntax it should look like. I actually don't know off the top of my head. Does that look right? Yep.
Looks good to me.
All right. Unit test Python. Just gonna double check everything. All right, so stuff equals upper. Oh, I need this. All right. I can also test like type equals int as well, just to test the type. So if I wanted to run that, cd into Python, then Python recursion spec. So one test ran, one it succeeded. I could add more if I wanted to. I could also import other functions as well. And even here, like I don't even technically need this else statement. Oh, I'm just gonna leave that there. I can actually just do that and it should still work.
For your
But-
first conditional, should you put 0 also?
Oh.
Or x equals 0?
Or x equals, yeah, I guess. Just return 1. So it still works. All right. Is that helpful?
Yep, thank you.
Cool. All right. What else? So I think also yeah. Do anybody else want to go over anything else? And we can see if I were to call this like factorial 5. Where is it? If I added some breakpoints. Let's see if this works. Oh. No. Where is it? It's been a while since I've done this. Load all stack frames. So you can see the call stack here. This factorial 1, 2, 3, 4, 5. And now it's being removed from the stack. Yeah. So that's how you can visualize the call stack in VS Code as well. Anybody else have any questions? No. All right.